McKinsey is replacing the ecosystem with the newest minigame, Seawolf, or Ocean Cleanup. This is by far the most difficult one out of the three currently active. The workload is high, the objectives are not always clear, and the logic is kind of weird. But fear not, in 20 minutes we will show you everything you need to know, from concepts, interface strategy, to examples, and more. Feel free to use the timestamp to rewatch the important parts. You are on a fictional ship called the Seawolf, going to 3 so-called sites, each contaminated with a different kind of waste. Your job is to clean them up using 3 treatments, one for each site. Each treatment consists of 3 different types of microbes. Each microbe has 3 numerical attributes and 1 binary trait, as shown in this microbe card. Each site, on the other hand, is defined by its requirements, also with 3 attributes and 2 traits. The numerical attributes come in ranges, and the 2 binary traits are either desired or undesired. The overall goal is to select 3 microbes so that, number 1, the average value of attributes falls within the required range. Number 2, at least 1 microbe has the desired trait. And number 3, none of the microbes has the undesired trait. Each treatment of each site is graded by an efficiency score, which is sometimes also called the effectiveness score. The maximum is 100%. To reach it, you must satisfy all characteristics-related criteria. Each time you fail a criterion, either of attribute or traits, the effectiveness of your treatment will be reduced by 20%. For example, if a site requires an energy of 3 to 5, and the energy average of all selected microbes is 5.33, you lose 20% here. If your treatment also doesn't satisfy the required range of other attributes, like adhesion and speed, you lose 20% more for each. So for attributes alone, you may lose up to 60%. For traits, if none of your microbes contain the desired trait, you lose 20%. The maximum deduction here is 20%, and there's no plus point for having more than 1 desired microbe. On the other hand, every time your microbe does contain an undesired trait, you lose 20%. You may lose up to 60% if all 3 microbes have the undesired trait. From all of the above, the minimum efficiency score is actually negative 40%. Hopefully, you won't be that bad. The efficiency score is not the only thing you will be evaluated on, though. More on this later. Within this year, McKinsey will replace the ecosystem with the Seawolf minigame, but the general game structure is still the same. As of now, the Seawolf game typically appears after the ecosystem and the Red Rock game. The time limit is fixed at 30 minutes. Even if you complete the other 2 minigames early, you can't carry the remaining time over to Seawolf. Within those 30 minutes, you are free to allocate whatever amount of time between the 3 sites. All tutorials are untimed. Unlike the other minigames, time management is a real issue here as the workload is quite high, especially when you are not familiar with the interface or the flow and strategy of the game. There will be 60 decisions you have to make in just 30 minutes, so about 30 seconds each. Some decisions require multiple calculations. You have to be at a very efficient pace to keep up. In each of the sites, you will do 4 to 5 small subtasks called steps. McKinsey wants you to feel like these are baby steps toward the ultimate goal of selecting the 3 microbes for each site. But in fact, many of these steps are independent and have no carryover to the next ones. Here's the overview of all steps. Don't worry if you can't catch all of these on the first watch. Once you get your hands on the game and do a few practice rounds, things will make much more sense. Step 1. Build microbe profile. The game will ask you to pick 2 characteristics, either trait or attribute, to create a preferred profile. Actions in this step do not affect any other step. Step 2. Categorize microbes. You will be presented with 10 microbes and must decide whether to use each of them for the current site, reserve for the next site, or reject it. This step does affect step 0 of the next site, but it won't affect the next step. Step 3. Build prospect pool of 10 microbes, of which 6 are already given. To select the other 4, you will select 1 out of 3 microbes in 4 selection rounds. The prospect pool created in here will be used in the next step. Step 4. Create treatment. From the 10 prospects in step 3, select 3 microbes to form the final treatment, as close to 100% efficiency as possible. This is the final task of the site, and it won't affect any other step or site. On the very next site, you will have a step 0, review microbes. This is like a mini step 2, where you will, again, categorize microbes into either this site or no site. Of these steps, step 0 can only appear in site 2 and site 3. The remaining steps are consistently present in all 3 sites. You have to go through all these steps in chronological order. So all in all, there are 60 decisions to be made in 30 minutes, or 30 seconds per decision. If you are not prepared, this can be quite overwhelming. Now, let's dive even deeper into each step using the realistic interface of our simulation, which you can access via the link in the description. In step 1, you will build a microbe profile by choosing 2 target characteristics out of the 5 provided. These can be either 2 attributes or 2 traits, or 1 attribute plus 1 trait. Basically, they want you to decide which characteristics you would like to focus on. The screen contains a site card on the right side with full information including 3 attributes with their required ranges and 2 traits, 1 desired and 1 undesired. The microbe profile setting panel is on the left-hand side. The interface is pretty straightforward here. Choose a characteristic by clicking on the switch. For attributes, there are also sliders for you to choose the min and max values. You have to choose 2 target characteristics. If you don't have exactly 2 switches turned on, you can't advance to the next step. You are free to change your selections as long as the result is not yet submitted. But once it is submitted, you can't go back to change your selections. Now, despite the tutorial giving the impression that setting a certain profile here will affect the microbes that appear in later steps, that's actually not true. All of the reports we've got so far say there's absolutely no carryover. If this doesn't affect the overall efficiency score, does it even matter what you choose here? Well, similar to all other mini-games in the McKinsey Solve, you will be evaluated based on a combination of both product score, aka the efficiency score in this mini-game, and the process score, whatever behaviors you demonstrate throughout the process. More on this later in the video. Our strategy for this step? Choose one logic, one approach, or one methodology, and stick to it consistently throughout all 3 step 1 of all 3 sites. For example, my approach is to treat the carryover as if it's real and make selections that maximize my success chance. I would pick the 1 desired trait and the hardest to meet attribute. Specifically, pick the attribute with a narrower range or further away from the center. Don't forget to use the slider to select the attribute range as close to the required values as possible. In this step 2, you will be presented with 10 microbes, 1 by 1, each with a microbe card of full information about attributes and traits. Your job is to decide to put them into either this site, next site, or no site at all, aka to reject it. The interface is also quite straightforward, with each of the microbe cards presented on the left 1 by 1. The site's information will still be on the right, like in the previous step, and of course you will still have full information about the current site. However, you will only have access to a limited portion of next site's information. So again, McKinsey is testing your ability to make decisions with limited data, something a real consultant has to go through every day. The control panel is on the left side below the microbe card. As you categorize the 10 microbes, their information will show up in the middle of the screen in each of the 3 columns representing the current site, next site, or no site. Notice that within this step, you cannot go back to the previous microbe. Every time you categorize one microbe, the decision is final. Again, despite McKinsey making it seem like your decision here is going to affect the overall game, this step does not affect steps 3 and 4. Basically, no carryover in this site. The only small thing it does affect is step 0 of next site. But that step 0 will pretty much have no effect on the other steps on that site. More about that later. Like I said in step 1, my strategy here is also to stick with one logic, pretend the carryover is real and try to maximize the success chance. And to do that, the most crucial tip is to prioritize the current site. Specifically, if a microbe has even the slightest chance of being beneficial to the current site, keep it here. If a microbe has absolutely no chance of being used in the current site, consider it for the next site and repeat the same check. If a microbe has absolutely no chance for either site, and only then, you may reject it. Think of step 3 as a baby step to select the final 3 microbes in the end. Here though, you will only need to narrow down your selections to 10 prospects. 6 of the 10 will be given. You will pick the other 4 prospects. You can see that 6 prospects and their information are displayed here in this panel, and there are 4 empty slots left. To fill those slots, you will be presented with 3 candidates on the top panel of the screen. You must pick 1 out of 3 in each round. And of course, there will be 4 rounds. The game will ask for your confirmation every time you make a decision, and once confirmed, there's no going back. Unlike in previous steps, for the first time, step 3 and 4 are connected. You will see all of these 10 prospects again, so choose wisely. Here is where I usually share my tips and strategies for the step, but the methodology here is too important to be relegated to a brief mention. It deserves a proper section for itself. But let's quickly go over step 4, and we'll discuss the fit concept again. It will be much easier to grasp. In this step, you will select 3 microbes from the pool of 10 in step 3 to form the official treatment. The efficiency score will be given upon your decisions here. The interface is again quite straightforward, with the site information on the right side as usual. All 10 microbes from the pool will be presented with their data. Your selected microbes will go to the section below. You are free to add and remove microbes until you are ready to submit. This is the final step, and the game designer is more forgiving. Not that it really helps much. This is the final step of the current site, and there will be no carryover to the next site. Now let's talk strategy. The fit concept. The idea is to create a system to quickly and efficiently evaluate the fit level of a microbe to a site. There are the desired fit, neutral fit, and the unfit. On one end of the spectrum, the unfits are absolutely unusable for the particular site. For example, if the microbe has the undesired trait of the site, it's an automatic unfit. Also, if an attribute value is too far away from the attribute requirement of the site, it's also an automatic unfit. For example, if the attribute requirement range of a site is from 1 to 2, then every microbe with an attribute value of 5 or higher is unfit. Think about it. Even if you can find 2 other microbes with attribute values of 1 and 1, the average will still be 7 divided by 3 equal 2.3, which is outside of the requirement range of 1 to 2. To give a name to this, we call it the fit range. It is a range in which a microbe's attribute values have to fall within for it to fit. Like in the above example, if the site's requirement is 1 to 2, fit range is 1 to 4. If the requirement is 1 to 3, fit range is 1 to 7. That means every microbe with the attribute value higher than 7 is an automatic unfit. Requirement of 9 to 10, fit range is 7 to 10. Requirement of 8 to 10, fit range is 4 to 10, and so on. In fact, it helps to memorize this table of common requirement ranges, so in the real game, you don't even have to think or calculate. For what it's worth, you should probably print this table out. There's a link in the description for you to download a nicely formatted and printable version of this for free. There, you can also access our simulation of the Seawolf minigame. Now going back to the spectrum, any microbe with attributes values within the fit ranges is a fit one. If it has the desired trait of the site, then it's a desired fit. If it only has the neutral traits, it's a neutral fit. Quick quiz for you. If the microbe has the undesired trait, is it a desired fit or a neutral fit? Just comment below either desired fit or neutral fit. My answer key will be in the description. So, in our treatment of 3 microbes, we will need at least 1 desired fit. The rest can be neutral fit, but none can be unfit. Play a few rounds and you will find that this big and beautiful fit blueprint is very, very powerful. In most sites, more than half of the microbe candidates are unfit. You can quickly reduce the workload by half and focus on the nuances of selecting the best options from the 2 types of fit. Once you submit your selection and finish step 4, you will move to the next site, starting with step 0. You will review all microbes from step 2 of the previous site and choose to keep them here in the current site or to reject them altogether. The interface here is nearly identical to step 2, except that there's no next site. That next site you see in the previous site is now this site, and the full information of this site is now fully displayed. If you choose to keep a microbe, it will reappear in step 2 of this site, but already categorized. You won't be able to reject or send it to the next site. Other than that, your actions here will have 0 carryover to any of the future steps or sites. You can approach this step 0 in the exact same way you do with step 2, using the big and beautiful fit blueprint. It's normal and even expected that you change your microbe categorizations upon learning the full site information about requirements, so don't be afraid to treat step 0 as an independent task. So to sum up everything we talked about so far, step 1. Pick the desired trait and one attribute that seems hard to achieve, aka the one with an extreme required range, or in other words, the one with a narrow fit range. Step 2. Categorize microbes into either this site, next site, or no site using the fit blueprint and prioritize the current site. If a microbe is not unfit for this site, put it in this site. If the microbe is unfit, consider it for next site. If the microbe is not unfit for the next site, put it in the next site. If the microbe is unfit for both this site and next site, reject it. Step 3. Choose a pool of 10 microbes, of which 6 are already given. The other 4 will be selected through 4 rounds, each round with 3 candidates. For every round, eliminate the unfit right away. Those are the ones with undesired traits or an attribute outside of the fit range. Pick the desired fit right away. When there are 2 or more neutral fit candidates, prioritize those with hard attributes, i.e. those with narrow fit ranges and few microbes within those ranges. Step 4. From that pool of 10 microbes, pick the final 3 for the treatment. Again, rule out the unfit microbes. Usually there are still a few unfit microbes at this point. You will be left with about 4 to 6 microbes, and there aren't that many combinations you can try. Keep in mind that in roughly 1/3 of the cases out there, there is no 100% efficiency score treatment. Just come up with the best you can, settle for 80%, and move on. Similar to other mini-games in the McKinsey Solve, you will be scored based on a combination of product score and process score. Product score is the efficiency score of the treatment. This mainly comes from step 3 and 4. The other big part is the process score, coming from all of your interactions with the interface. Similar to other McKinsey Solve mini-games, here are some of the tips. Number 1, be consistent with your logic. At times when you have to make decisions without perfect data, don't stress over making the ultimately correct decision. Just focus on making the best decision given the data you have, using one same consistent logic. In step 1, for example, if your logic is to choose the desired trait plus one hard attribute, stick with it. If you have a slightly different logic, so be it, but stay with it through 3 sites. Number 2, avoid random clicking or trial and error. McKinsey's system penalizes inefficient exploration. Instead, you should make deliberate actions backed by a consistent logic, as we talked just before. Number 3, plan your approach. Know exactly what you are going to do and just go in there and execute. There's no time and place for thinking at that point. Playing with the simulation and getting a lot of reps before the real game is very beneficial. So that's everything you need to know about this mini-game. The rest is just getting yourself a lot of practice. You can do that with our realistic simulation. The access link is in the description. See you there.